Hi guys, today we're going to talk about the volume of spheres as well as the surface area of a sphere. So the figure that you see to your left is a sphere. We can find the volume of a sphere by using the following. V equals 4/3 pi r cubed. Right, so V equals 4/3 pi r cubed. When you consider a sphere, what you really can be thinking about is a ball. We can also find something called the surface area of a sphere. So be mindful, right? The surface area is all the areas that you can touch on the sphere, which is found by using S equals 4 pi r squared. You might also see this referred to as SA equals 4 pi r squared. Either way, we're talking about surface area. So let's do an example. With example number 1, the directions say to find each measurement, give your answers in terms of pi. We want to find the volume of the sphere. So in order to find the volume of this sphere, what we want to do is we want to use our volume formula. V is equal to 4/3 pi r cubed. Be mindful, r is your radius, which is 5. Therefore, V is equal to 4/3 pi radius 5 cubed. In your calculator, what I think that would be most beneficial to you is open up a parenthesis, put in the fraction 4 divided by 3, close your parenthesis, hit enter. Then multiply that by 5 raised to the third power, hit enter. And what we end up seeing is 1.666667. Hit your math button and enter 2 times, which pulls up your math frac, which allows you to go ahead and put that into an improper fraction very, very easily. 500 pi over 3 millimeters cubed. Okay, so that is our answer in terms of pi. With question number 2, you're asked to find the volume of the sphere. Be mindful, what you have here is the diameter of what's referred to as the great circle of the sphere. Okay, the great circle of the sphere is as if we took a plane, sliced it through the very center of the sphere, separated the hemispheres, looked at the shape. That shape that was a result would be considered the great circle of the sphere. Okay, it's the widest circle that can be made when you cut a plane through the circle. That being said, the radius of this sphere is actually 8 centimeters. So if the radius is 8 centimeters, and I want to figure out the volume, V is equal to 4/3 pi r cubed. So once again, when you input this into your calculator, hitting your math frac button to get the easy improper fraction, you end up with 2048 pi over 3. Of course, we're talking about centimeters cubed. All right, looking on at number 3, you are asked to find the volume of the hemisphere. Well, be mindful, what is a hemisphere? A hemisphere is exactly half of a sphere. So when we go to use the formula to find the hemisphere, you want to take your sphere formula and divide it by 2 right from the beginning. So V is equal to 4/3 pi, our radius is 2, cubed over 2. Why divided by 2? Because it's a hemisphere, right? It is only half of our sphere. The way that I think is best to deal with this as far as your calculator is concerned, really truly, is to deal with the numerator first. Deal with the numerator first. Then apply your divide by 2 in the denominator. So if I do that, V is equal to, I'm going to take in my calculator 4 divided by 3. I'm going to hit enter on that. I'm going to put it in times 2 cubed, which obviously gives you 3. The result is 10.666667. Obviously, we know pi is still with that. However, you're not going to use your pi button at this point. Leave it alone. Take that 10.66667, divide that by 2. What you get is 5.333 repeating, right? Hit your math button, enter 2 times, and you end up with 16 pi over 3. That is your answer in, of course, feet cubed. All right, looking at number 4, you're asked to find the radius of a sphere with the volume of 7776 pi inches cubed. Well, we want to know the radius of the sphere. So if this is our formula to find the volume of a sphere, but we already know what the volume is, plug in 7776 pi in for V. Set that equal to 4/3 pi r cubed. So my ultimate goal here is to get that r by itself. In order to do that, what I want to do is multiply each side by 3/4, right? If you multiply each side by 3/4, that allows the 4/3 to go away on the right-hand side. And on the left-hand side, what you're left with is 5830 pi is equal to pi r cubed. Divide each side by pi, and you're left with 5830 is equal to r cubed. You might be thinking to yourself, I remember learning how to take the cubed root back in Algebra 1, but I have forgotten how to do it on my calculator. Well, it is your lucky day. What you're going to do is hit your math button on your calculator. You're going to arrow down to number 4, and you'll see cubed root. Hit enter on it. Put in 5830 into that cubed root. Hit enter. And what you'll end up seeing is that we get 18 as our radius. So r here is equal to 18. Of course, we're talking about linear inches since it's a radius. Moving down to the next couple questions here. If I want to find the surface area of a sphere, remember that is all the areas or all the pieces of the sphere that I can actually see and touch, right? So the surface area is equal to 4 pi r squared. We're going to go ahead and put in that r, so 4 pi 7 squared. 49 times 4, we end up getting 196 pi. We're talking inches, not cubed here. We are talking squared inches. Why? Because of this little word area, right? When we see area, everything is squared, not cubed, not cubed. Okay, looking at number 6, same concept. We want to find the surface area of the sphere. However, you do not know the radius, but you do know that the diameter is 20. If the diameter is 20, we know that radius has to be 10. Plugging in our data into our surface area formula, surface area is equal to 4 pi, r is 10, squared. Therefore, we end up with 100 times 4, which is 400 pi, you guessed it, meters squared. All right, looking down at number 7. Describe the effect of each change on the given measurement of the figure. Well, just like in a couple of the other notes that we've given, we're going to apply the same logic here, but be very mindful, right, of the words that are involved in the questions. With number 7, we want to find the surface area. If the we want to figure out the effective change on the given measurement of the figure. So what would the change be on the surface area if the radius here is multiplied by 4? Well, we're not looking for volume. So really what I want to do is I want to take 4 and I want to square it. And what I end up finding out is that when we apply a multiple of 4 times the radius, we end up with the resulting surface area is 16 times larger. So the new surface area is 16 times larger than the original. Okay, the new surface area is 16 times larger than the original. Looking at number 8, we want to be mindful, right? We are now talking about volume. So when talking about volume, if we multiply these dimensions by 1/2, really what we're doing is cubing them. Okay, let's not forget our basic fundamental algebraic properties. This gives us 1 cubed over 2 cubed, which is really 1/8. So really, when I go to look at this, the effective change on the given measurement is that the new volume is 1/8 as large as the former. All right, looking at our last two examples for today, number 9 and number 10, we want to find the volume of each composite figure. Sorry about that. Find the volume of each composite figure. Round to the nearest tenth. All right, we have a little helpful hint here which states to find the volume, add the volume of the cylinder and the volume of the hemisphere. So let's go ahead and do that. The first thing that I would want to consider would be the volume of the hemisphere. So I'm going to call that my step number 1. Step number 1, finding the volume of the hemisphere. I know that that's 4/3 pi. My r here is 9 cubed divided by 2, of course, right? Because we're only considering half of the sphere, right? It's a hemisphere. Once you calculate that, we get 486 pi. Okay, so that is our volume of the hemisphere. The second thing that I want to consider is the volume of the cylinder. Okay, volume of the cylinder. We'll put a little h down here. That way we know we're talking about hemisphere here. The volume of this cylinder, don't forget guys, is pi r squared times the perpendicular height between the two bases. When you calculate the volume of the cylinder, that ends up giving 972 pi centimeters cubed, of course. Our last step here is to actually find the total volume. So we find the total volume by taking 486 pi plus 972 pi, which leaves us with approximately, remember we're rounding to the nearest tenth per our directions, leaves us with about 4,580.4 centimeters cubed, because we are in fact talking about volume. Now on number 10, I do want to address this one real quick. It says to find the volume, subtract the volume of the hemisphere from the volume of the cylinder. One thing I do want to address is in your homework, you're going to see problems that look like this for this lesson, and you're going to kind of be wondering, you know, it's going to look kind of strange to you. So when you see a situation that's when it's inverted like this in your homework will be shaded a little bit, okay, in this area. You'll see it'll be a little bit darker right here. And what that means to you is we want to consider that figure without that yellow portion included. Obviously, it's not going to be yellow on your homework, right? It's just, like I said, it's going to be shaded a little bit more, but that's what we're asking you, right? Is if we took that out of the figure, right, what would be left? So going from that basis, the first thing that I would want to figure out here is obviously the volume of that cylinder, right? The volume of the cylinder in itself, right? As if it were completely whole, what would the volume be? Well, the volume of that cylinder would in fact be pi r squared times perpendicular height, which would yield about 63 pi. My step number 2 would be to figure out the volume of the hemisphere. To figure out the volume of that hemisphere, I'm going to take 4/3 pi r cubed. You guessed it, divide by 2, right? Because it's a hemisphere. This actually leaves us with, once you calculate everything, 18 pi. And this guy is totally in my way, so I'm going to give myself some space. Be mindful, if I were going to take out that yellowed in portion of this figure, I would obviously want to subtract. So my step number 3, instead of adding like we have done in the past, we want to subtract to find the total. So your total ends up being 63 pi minus 18 pi. Once you calculate that, I'm going to change colors here so we can see a distinction, into your calculator, you end up with 141.4, and we're talking inches cubed. All right, guys, so that completes this lesson. Hope you guys are doing well. Look forward to being back in class with you at some point. If you have any questions, make sure that you post to Edmodo or email one of us teachers. Have a great day. Bye.